just introduce yourself and take off.
Yeah, hi, I'm Emery Brooks from I'm at the UT Health Science Center in San Antonio, Department of Biochemistry, and I'm going to talk to you about application generation with GenApp and explain what that is. So it all started with the CCP SAS, and I'll explain what that is, and I'll talk about the framework and some of the future things we're going to do. So the CCP SAS project is this internationally funded collaborative computational project for small angle scattering. There's been some other CCPs. The UK likes to fund these. This is one, joint NSF UK, and I'm one of the primary investigators. And I'm primarily responsible for the computational infrastructure for this computational project. Collaborative computational. Small angle scattering is a biological technique that's done at the lab with a benchtop or at synchrotrons, the giant particle accelerators, or neutron sources, in which they take a collimated beam of monochromatic light or neutrons and hit some particle in solution and get scattering information. If you're familiar with crystallography, X-ray crystallography, if you've actually seen any kind of an X-ray crystallography data set, they're looking for these sharp peaks. But near the beam, where it diffracts, near the beam stop, there's always this fuzziness. And small angle scattering is interested in that fuzziness. And from the data that you can get from one of these data sets, you can determine things like size and shape, and you can determine potential structures and do rigid body modeling. Let's say you have a bunch of atomic structures and you can move them about and compare them with the small angle scattering data. Or let's say you want to refine a structure, you can use that to compare against small angle scattering data. Now, this is a wide range of computational time and complexity involved. Some are simple, quick transformations. Others are long-running Monte Carlo type or molecular dynamic type jobs that can be running on lots of processors simultaneously. So entering this CCP SAS project with three initial software packages. One is the SASE package out of NIST, National Institute for Standards and Technology. Excuse me?
It's true that...
All right, please be on mute unless you have a question for Emery. Thanks.
Oh, okay. So one package was the SASE package from NIST in Gaithersburg, Maryland, at the National Institute for Neutron Research. There's another group out of University College London that had a software package, and I have the US SOMO package, which is involved in small angle scattering as well as complementary fields. And we wanted to set up an infrastructure that could attract others. So my choices at this point were, we can write something, web interface by scratch. That was one of the ideas, was having a science gateway or web access to it. But instead, I created, let's give some of the considerations. So some of the things that came up are that the multiple labs have the issue of deployment, generating versions for multiple software environments. Software environments change, compilers change, or somebody's got some old version of some operating system or some incompatibilities with other software. The computational infrastructure in this field and in a lot of other scientific fields are somebody comes in, there's a postdoc or there's a research scientist, and they write something to do a job, and it's useful and it works, and then somebody moves along and nobody can change it anymore, there's no access to it, or something goes, only works on some version of some operating system or other restrictions. And these labs are generally don't have a lot of extra funding. And a lot of times their experience with computer science people, if you bring somebody in, it becomes sort of a negative experience in terms of there's lots of complexity brought on, and they don't have the time for it, and they don't have the funds for it. So one of the things we want to do is also to help sustain the legacy of important scientific codes. So I created this framework to basically wrap these scientific modules, which are typically can be decently defined in terms of input and output, and said, okay, well, just define your input and output and read and write JSON formatted data. Input and output has to be defined on a sort of extensible set of data types. And that's all and then you can create an application by saying how you want to organize your modules. And then everything else is done by the system. And the idea is that it's extensible. So right now we generate HTML5 PHP for web server end. We also generate Qt3 C++, Qt4 C++ applications, all working on the same underlying modules. We have two Google Summer of Code students recently funded. One that's going to work on the Android version to generate Android code, which really comes off Qt5 C++, and another one's going to work on Java. And so you can sort of take the same set of underlying modules and generate applications that are usable. And then if there's changes or there's some new target language or something, we can create something else. And the computer science people can be sort of limited to this side of things, and the lab scientists can just define their modules. So let's talk about the framework a little bit. I wish everybody this sharing worked well. We'll have to do this again once we're maybe on Google Hangouts, where I can show the website live and everybody will have a chance to actually see it in action, because it's kind of nice. But let's go ahead and talk about the framework from the user perspective. So my first user was Joseph Curtis of the SAVSI code at NIST. And he has a bunch of Python, small angle scattering for neutron studies work that his user base uses. And he has a package that he always has a hassle getting people to install properly, and it takes too much of his time. So he was the first user, and he wrote his instructions that are up on our wiki. Basically, there's a few files. There's a directives file that you edit to define global options. There's a menu file that you edit to define which modules you're going to use. And then you define the input and output of each module in a JSON file. And it's expected that each executable will read and write JSON and only put valid JSON to standard out, because our basic thing is to read standard in from JSON, write standard out to JSON. Once they've set up these three groups of JSON modules, they can just run this one command line app, and it builds all the code for whatever languages they selected. And in this case, we have it set up on a web server, and then he can just go to his web link and see the new version. So if he changes things, he can has a quick development regeneration cycle. So the directives file has things like title, application name, what target languages they want to generate. There's footer information, executable path. There's currently some language-specific data. There's helper applications which can be used in some of these languages. There's an application configuration JSON also that has some sort of live data, so you can adjust things like feedback email addresses and ports and some of those things for the web server. Colors, I should organize that into just a colors JSON entry with some sub-entries. If you're not familiar with JSON, some people call it a readable XML, but it's used a lot in web technologies nowadays. And I find it relatively easy to read. And brackets are arrays. Braces define name value pairs, and they can be nested as much as you want. Here's an application configuration JSON. It just has some mail information. SMTP if you use it. If that's not, it'll use your send mail or your local thing. There's some messaging ports for the HTML5 application. Resources. This is probably an interesting part to some of you, since we're talking science gateways. Right now, our infrastructure is we have local machine, which means run it on the web server. We have some attached compute nodes. We also, last summer, we had an Aravada link with an earlier version of Aravada that a Google Summer of Code student got working. But then Aravada advanced and GenApp advanced, and we're going to get all that straightened out this summer with Google Summer of Code. And there's some default policies and things. One of the nice things about defining everything in JSON was that everything's easily extensible. I can add new fields and tags and use them where I need. Okay. We have to choose something for the menu at some point, although the languages are extensible. Everything's extensible. Even the target language business is defined in JSON, so we can assemble from code fragments. Final code is written in JSON. But I'm giving you more of sort of a user's perspective on all this. We chose for the SASE, for initial implementation, two-level menu structure, where we have groups of modules defined in this menu file. And so we have an entry in the JSON for the menu definition, and it ties directly to what you end up seeing on the screen. So here we have tools, and then under that tools button, there'll be three options of these three different modules. And under the build, there's that. Here's more detail on one of them. So we have an icon that shows up, and then we have the buttons for each individual module that gets run. Here's a screen of a module, and okay, this has some information, a sort of layout. This is the HTML5 PHP version. We have a file management, a job management, ability for users to register. We have a feedback tab. There's also an optional docs tab if you add the information in your directives. You have sort of your submenu module choices. You have this, and it's been commented, maybe it's somewhat simplistic, but we have an input area where they define their inputs, and an output area where they get their outputs, and in between there's a submit. So here's an early, one of the early tests where we have a HTML5 and PHP backend and a Qt C++ version side by side. So they're not identical looking, but the functionality is the same. And that's one with a simple plot output. Here's a more recent shot of a screen to be more exemplary of what's currently happening. We have we're using Float for the HTML5 PHP plotting, and for Qt, we're using QWT plot. We also have a molecular viewer integrated, so that if you want to output an atomic file or PDB, it will just show up in your output as a three-dimensional structure that you can rotate, play with, and change.
Hey, Imre, I have a couple of questions at this point. Can you say a little bit about how you chose Float versus some of the other options? Maybe you didn't do an exhaustive search, but I'm curious. And also, Can you say a little more about JSMol?
Yeah, JSMol is, well, let's answer the flock question first. I looked around for, I had pretty much chosen jQuery for my PHP HTML version for the JavaScript side, and Flock seemed to be reasonably good. It had a nice open license. There was another plotting function program plugin that I saw, but the commercial side was more restrictively licensed. So there are commercial users of this software, and we really needed to have nice open licenses. And Flock seems to work. It has some nice pan, zoom. We have lots of control capabilities on it, and we haven't run into a problem with it yet. But we don't. We're not restricted. I mean, we went down a pathway, but we could change that by changing those subfragments or creating a variant of what we have. So it wasn't a terrible decision that we have to live with forever if something better comes along. JSMol, it's okay. It's kind of heavy. I mean, this is pure JavaScript, but it brings along with it all of Java converted to JavaScript. I guess they use the JMol code written in Java, and they use some Java tools that generate JavaScript from Java. But it works. It has, the capabilities that biological researchers are interested in a viewer, and it's functional. Something better comes along, that'd be fine. But this was really, we didn't see a lot of choices in terms of molecular viewers that were pure JavaScript. I don't know if there's anything else out there. Certainly not in the biological field that I've seen. That knows things like atoms, the standard organic molecules and atoms and residues and those sorts of things. So it works. I mean, one of our restrictions was no Java. We didn't want people to have to load things up. We wanted just to work in a modern web browser for this variant of GenApp produced HTML5 PHP code.
That's very apropos for our AD conference.
Yeah. So it's we just want to make it as easy as possible for the user to get there and get what they need done without a lot of extra overhead.
So, Emery, do you know if JSMol has a molecular, is it an editor as well, or is it just a molecular viewer?
We're just using it for viewing right now. I haven't really, if JMol can do it, if you're familiar with JMol, then JSMol should also be able to do it.
Okay.
So there is a command line access. There's all kinds of interesting things you can do with JSMol. But right now we're just using it for viewing. I can show one live, but unfortunately not everybody has my interactive screen access or can see my shared screen. We can take a look at it once we get through the main talk for the people that can share. Shall I move on?
Yeah, thank you, Emily. Yeah.
Okay. So all the fields, we have this extensible set of module fields, and you probably can't read this, maybe if you have a local copy, but this is, it's a copy at one point of some of the different input fields that can be defined in your module, input and output fields, and this sort of a matrix. We'll probably improve that. We've added to this, and there's more. It's not really appropriate maybe for a 2D matrix. Each type should have a whole set of entries is what's valid for that. Some of these say HTML5 only, and that's because our focus recently has been on the HTML5 version since it's in production, and so the Qt version is a bit lagging, but we'll catch that up. Okay, this is sort of the all-in-one page. So it has the module definition, a module screen, what's actually getting sent to the executable, and what is expected back, possibly from the executable. So when you define a module, you sort of, again, I might redo these and have sort of a sub input and output section, but nevertheless, what we have now is an array of fields that have roles of input or output, and then they have their identification, labels, types, and whatever other attributes are needed to well define the field. It's ordered, and so their output's going to be, the screen's going to be generated. The user interface will be generated in that order. And so once you've defined your input fields and their types, then this field ID input 1, when the user presses submit, whatever's in user ID field 1 will end up as the value of that ID, which was input 1. So it's basically a one-to-one mapping of your IDs to what you're going to get as input in your JSON to your executable module. And similarly for output, whatever you have for output, it's going to look at your executable output when it returns, and it's going to map what you send to that next executable in your executable output to fields on the screen and display them, including atomic structures or plot data or whatever. These are sort of simple. This one actually shows a message on there, AP messaging that can be done live during the execution, and that's really extra. The important parts here are output 3, which maps to something. These other bits are extra. Is that understandable? Is that?
Yeah, we're good.
Okay. So I'll talk a little bit about messaging and the execution model. So there's different execution models going on. This framework doesn't restrict the execution model, but it utilizes certain methods for execution right now for these current target languages. The web browser version basically does an AJAX call to the PHP that's generated, which then sends data to your, actually runs the module's executable, and then when the results return, it goes back to your web browser. For the Qt version, we just did a direct execution where it calls your module's executable and comes back. Now, excuse me. This is the same executable, but one it's being run sort of directly without any network involvement. The other one it's being run through some chain of events. We could have a Qt version that calls a web service or vice versa. There's lots of options there, and one of the things we wanted, since some of these executables are long running, is some kind of a live messaging, which we implemented in the HTML5 PHP version. Right now we're using a UDP server for sort of fire and forget messaging to not slow down any executable, waiting on some connection that may or may not be available or clogged at some point. Because we're thinking about parallel jobs and these sorts of things. And then that connects using a ZMQ to a WebSocket server, which talks to the web browser. So we have the second WebSocket channel that's feeding information to the web browser. So the first issue we found out was that TCP connections don't necessarily last forever behind some people's firewalls. And so for jobs that are running for hours or days, they can't just leave that open. So we changed to sort of a two-step execution model where we get an immediate acknowledgement from the PHP and start a monitor daemon that watches that executable and then sends back some messaging. We also have a watchdog timer on the web browser that checks for results in case something failed in the messaging. and then there's sort of a get results. This however had a second added benefit when we did this, is that now it gave us the ability to reattach to previously submitted jobs and get the results or to continue on. Last summer, with the help of Suresh, Nadeem had a Google of Summer code project to integrate Aravada, and he got it working sort of as an extension of what we previously had for submission to resources, to cluster managed resources, using, as I mentioned earlier, a previous version of Aravada with a previous version of GenApp, and this was working for both the HTML5 PHP and the Qt3 and Qt4. That's going to be refreshed again this year. File management. I'm going to talk about that for a minute. So ideally, everything should come in and out of the JSON, but that's not, it wasn't practical in the SASE case because they had a lot of dependencies in their code that sort of required the structure of having some directory created and files existing for the next step. I'd like to see it all coming in and out of JSON, and so that workflows could easily be defined on this at some point. And we had unique run directories for each step, but the SASE code, the Joseph Curtis NIST code, they expect their outputs, and so this created this complication of projects, which maybe isn't so bad, but we have the option of running under projects with persistent directories, which of course implied that we now have to lock projects because you don't want clobbering of output in a persistent directory, and it brought up the whole file management issue. So we created a sort of virtual cloud file of jobs that they have access to. This is sort of an early shot of the screen. It's been improved a little bit, where they can use, we're using JS Tree, I think, as a widget that's been with some plugins. And they can basically browse their user file tree structure and download and remove and trim files. There's a context menu for right-clicking on there. And they can get some different types of formatted output to bring it over to their local system. There's also job management, of course, because you have lots of, you're submitting these things, and some of them are long-running. So this needs some more. I mean, this is our initial job management screen. There's some colors there because projects are locked, and it gives you some information about things that are the job that's locking a project and other jobs that are in the same project but aren't locked. And there's progress information, and you can scroll it over when you have it in front of you, and it has some more columns of data about it. And this gives you the ability to sort of clear a lock if something broke. That's mainly during the development process when they're writing modules and they don't exit properly. Remove jobs from history and reattach. This is a grid structure. We'll probably go to an organized tree structure because that widget seems nicer, and it's sort of easier to deal with when you get a lot of jobs. But reattach is something I don't say that much about, but Joseph Curtis always says, oh, that's so cool, because what I do is I'll start a job in the web at work, and I'll go home and I'll just connect to it, and even though it's still running, I'll get live updates and know where I'm at with it, or after it's done, I can go back and see everything. Brief demo, sort of at that point. Any suggestions, Marlon, as how I should handle this? Should I go ahead and do it for the people that it's available for, or should I close out and then do the demo afterwards?
How about we, do you have more slides?
I have a couple more.
Why don't you go ahead and close out, and then we can go to the demo, and also if there are any questions before you go to the demo, that would be a good time.
Okay, great. So immediate plans, future tasks. Okay, here's the framework again. sort of the general slide that we like to use. So current infrastructure, we have a server set up at the UT Knoxville. That's our entropy server, and it's got some bunch of GPUs on 2 of the compute nodes, and a bunch of RAM. Some of the codes that they're running, molecular dynamics codes, are CUDA coded. So there are some heavy compute jobs when they're doing some molecular space expansion, these sorts of things. And that's running the HTML5 PHP. And we also have some Indiana University Quarry nodes. We have a test site there where I set up demo accounts and we can play with. And there's also a track wiki right now with an integrated subversion repository. We've had students working at NIST. We had our first workshop using the infrastructure for SASE code last June. This all started in the fall of 2013 after we were funded. There's an Exceed, we got an Exceed allocation to test out the integration, which we'll hopefully use up this summer during Google Summer of Code testing, and we got Aravada integrated again. It appears we're going to have Oak Ridge's Titan for these jobs, running this infrastructure with a group there that's interested in utilizing the SASE code primarily. We also have a major, it's sort of been sort of alpha closed community, and at the end of May, there's a big international workshop in Grenoble where we're really moving into beta with the GenApp generated SASE code. So we've been making a lot of improvements to that.
Emery, how big is Titan?
I think it was #1 for a while.
10%'s pretty big.
Yeah, 10%'s pretty big.
What?
10%'s pretty big. I was pretty shocked when I heard it, actually.
What are they wanting to run with it? Run on
They're going to be running a lot of the SASE code. There's going to be a lot of molecular dynamics expansion. It's going to be associated with a lot of their biological research with neutron scattering and combined maybe with X-ray scattering. There's Paul Langen's group there, and they're going to be. So we're sort of working through the stages of making that happen. So. Yeah, it takes a lot of these codes for expanding molecular space. I mean, you can do, it's not the same as you're doing like, nanoseconds of molecular dynamics. It is, you're really moving things around a lot. And so you have to use sort of a torsional angle molecular dynamics. They do discrete molecular dynamics as in SOMO. That's what we use. That's another way. But the idea is to get expansion of conformational space in longer time scales, and then compute the forward scattering problem, and then compare that, screen that against experimental data. So there's lots of computation involved. A lot of these are long-running jobs. So on to future tasks. So right now, we have the Google Summer of Code coming up with the Java and the Qt5 version to finish off, and Qt5 has a nice, you can generate Android for it, so we're going to find out if that actually works, and what restrictions are present. I have a postdoc coming online in July that I have funded for 2 years, that he's going to be, his primary task is going to be with the framework and also wrapping the US SOMO code into the framework. So I want to move away from the, I want to solve some of the issues myself, and I've been too busy with the framework itself to do the US SOMO conversion, although I guess I could, but I have a postdoc funded for that. We are, as part of GSOC, also is integrating with the latest Aravada. I'm going to be working on some advances in job management and job management in terms of, super user sort of view through the interface to see who's running what and what state their jobs are in, and these sorts of things. And then also to redo the job management screen to organize it a little bit better. We also want to work towards either, Apache incubator status or potentially becoming part of Aravada. So there's some work that needs to be done to prepare the code for a change like that. Here's some question sheets. Right now I'm funded by the NIH and the NSF on this. We have some exceed funding with a bioinformatics core facility, Google Summer of Code. I'll have to add to that. And of course, the Aravada group, Marlon, PTI, Suresh, Raminder have helped along the way too, especially with the Aravada integration and infrastructure and getting the query nodes available. So, okay, so that's my basic talk.
Can I ask a question?
Certainly.
Can you go back 3 slides, please?
Let's see, 1, 2, 3. The resources slide?
No, one right before that one.
The GenApp Framework.
Yeah. So
Okay.
I'm a little confused about something fundamental, and I wanted to just clear it up. The GenApp Framework basically generates the user interface, right? But underneath, it's still running the original code?
Yeah, it's still running the original code somewhere.
Okay. Okay, thank you. That's my question.
Yeah, the scientist that wants to come and bring their code, let's say we're having meetings now somewhat. What's happened, somebody hears about this, and then some lab scientist said, oh, I have this code that does X, Y, and Z. And so what their task is to basically define their inputs and outputs and create an executable module. And the way this is set up is, right now we're running executable modules on Entropy, or if they can run on their own system. So if it doesn't run from that, it's still an issue. So the idea is probably to have, sort of a web resource is probably one of the better ways to go with that. We could set up, if there's some real particular environment, it could be in some virtual machine or wherever. It just needs to be able to run somewhere accessible by the application. And then we could, add what we need to the framework to execute it there. That's why we had sort of that resources list in the JSON defining the application, the directives JSON. And then each module can have some specific resource information, like I only run here, or just on these resources. So it's still the lab scientist's responsibility to make sure that their executable module runs somewhere that's accessible.
Okay, thank you.
Yeah. And we looked at also maybe other technologies for executing, but right now that's how we're running it. Any other questions?
Let's see a demo then.
Okay, so anybody that can't see the demo or just wants to listen, you're welcome to listen. But if you need to go, thank you for attending. All right, let's see what we've got here.
Paint a picture with your words, Emery.
Okay, so here's the one running on Entropy at University of Tennessee, Knoxville. So this is the basic, entry window. So if I reload, it'll just show this again. So there's that sort of the menu bar that shows these are the different choices to the left. He doesn't have the highlight help. I'll go to this is the production beta version that users are using right now. The alpha version, yeah, I threw floating help on things. So you can add, there's floating help everywhere, so that you can see different things. So there's a registration, so a user can register themselves. You can log in. Has my login information. It has the whole forgot password and sends you really crazy password that expires within 1 hour, and you've got to change once you use it. So it has some feedback. And then once you're logged in, you get some additional accesses like your file manager. So there's the file manager, and there's some different files that are out there, and I can select or use shift select and all these sorts of things. And then you can download. It's one of these various methods you want to download. There's the job manager. Once you're logged in, the user becomes user configuration, where you can select projects or create new projects or change your email address or password. There's a feedback, and this right now is set up as a feedback email address, and we're sending to Google Groups. And one of the neat things about this is that it also lets you select a job maybe you've recently run or one that's problematic. And then when you select that or multiple jobs, it will, along with this feedback email, send the JSON input and output and the standard error and the standard, well, the JSON output is the standard out and the standard error and an event log from the user's experience, and it'll all get attached to that feedback email, so it helps with debugging. There's a context-sensitive optional docs, so let's see if he's got that set up for this. If I click that, it's going to go to what I did last and bring up that page. So we can go to, let's see what we have here. I know the simulate is always a good one. There's Monomer Monte Carlo. This does a Monte Carlo simulation. There's also, we have one of the field types is what we call a local remote file. So I could browse something from my local server, or I can, from my local client system, or from the remote server, and select a file that I've already uploaded. And this also these both get mapped to the same input field in the JSON. You get sort of staged similarly. There's advanced input. There's more to it than just a flat screen. There's some options. You can have what we call repeaters. And so something can be based on another input value. So here, the advanced input, all these fields in the module JSON are tagged as repeats on this checkbox repeater. We also have integer repeaters and list box repeaters. So it gives the ability to have some sort of some interaction defined in the JSON for the user entry. So then
Emory has a question. What kind of limits have you hit with this approach? Because invariably people can write codes in all kinds of science codes in all kinds of strange ways, and it's sometimes hard to fully. Maybe you're not so much worried about the input file format itself, but there are lots of conditional cases for what the input file, or rather the input line format, the execution line format might look like. So I know you can't do everything, but where do what kind of things are you hitting, and what kind of solutions are you coming up with?
So the basic idea, a lot, at least in the small angle scattering field, the majority of these computations are, I have a set of inputs, I produce a set of outputs. So there, it's the module developer's responsibility to read and write valid JSON. And then also they have the bonus of associated files. And what format those files are, I don't care from this standpoint. The files are files that they use. So it's really, can you define your inputs and outputs on this set of data types? And do you want to push some types of validation and interaction between those input fields to the user interface, or can you validate it in your module and respond with a message box or something appropriately? So it's really not, it doesn't make a lot of, we haven't run into any issues yet.
So are
we
these?
did need some of these, you know, because really all we're defining is the user interface part of it, and that generates JSON, and it's their responsibility to read and write the JSON.
Emery?
But some of these, I had a quick question, and then Sudhakar can get this question. My quick question was: Are all the people that you're using or you're working with, these are all codes under their control, and they can modify them however they want?
Yeah. Yeah. Although there's some codes that are wrapped executables that are not under their control, but they can control the wrapping in between.
Okay. And sorry, Sudhakar, you want to go ahead?
No problem. So yeah, so I think you touched upon this briefly about validation. So do you strictly validate all the input and flag anything that is conflicting right now? I mean, a kind of a related thing is, so I mean, these identities for a field requires that, you know, the user is kind of familiar with the application itself and maybe with the input and some other thing. So there may be, you know, some need for an explanation of, you know, this field ID, or, you know, or if they are trying to add some, you know, input that is conflicting, you know, there should be some kind of a message box or something which either internally checks that, or you can give some just general information that, you know, if you set this parameter, then the other parameter cannot be such and such, and some, you know, some kind of a help or a hint kind of thing.
Yeah, there's user definable floating help on every field in the module. There's some things that you can sort of control by the checkbox input. So, you know, that field's not going to show up if I don't check this, and it won't appear in the JSON input if it's not checked, or any of its subfields. So there's some things that can be done at this part. In terms of the actual executable, the only thing it gets is standard input it reads, and it writes standard output. So there's really, when Nadeem integrated Arvado last year, he created a generic registration mechanism that ran when you generated the application as part of it, and it was just input, standard output. That was all that was needed. There's also, you know, staging of associated files, but that's, you know, okay, it's going to be in a directory, and the executable is going to have the files it needs and expects, which may be defined in the JSON. Otherwise, I don't know how it would be defined, and hard-coded or something. And they'll read it. So there hasn't been an issue yet.
Hey, Emery, can I ask a question? This is
Sure.
Terry. How do you specify the relationship between the form parameters? Like this one doesn't appear unless that one's checked.
So we have this repeater structure, so that when I add these fields, these are actually, there's an extra tag in the input file in the module JSON that says this field, for all these IDs for all these fields, they repeat. It's actually a tag. It says repeat, and it repeats on the ID of this field. Okay, so it's a way to define interrelationships between the fields that we found convenient. So this is defined as a repeater, true, in its field module JSON, and then these are dependent upon this. And then that way you can actually have a multi-level structure so that repeaters of different types can repeat on other repeaters. And we have right now 3 fundamental types of repeaters: checkboxes, list boxes, and integers. So that if, let's say I need how many files do you want to, 10, you want to process 10 trajectories or 10 PDBs or something like that. They can actually, select up to 10, and then it'll automatically create a bunch of whatever is repeating on that duplicates.
Okay.
Of that.
Can you do something like, say, if the value of this field is greater than 10, then enable another field?
Yeah, sometimes that's not currently implemented. We do have minimums and maximums.
Okay.
But the framework is so open, and the code, it's actually pretty nice to work with, that it wouldn't be that difficult to bring in new features. It's easy, and I'm doing it constantly. So to certain variants of it. So yeah, we expect that there's going to be, as we increase our module base and the people that are actually running things under it, that there's going to be some advancements. But we also want to make sure that we don't do it, that we put some thought into it to make it, the overarching goal is try to make this as simple as possible for the lab scientists to utilize. So that, let's try to do it in a sensible way. Okay, so this field, how are we going to link those together in the JSON input structure?
Right. I guess mostly I was curious about, whether you think you have to invent or use some sort of full expression language so that you can, are unlimited in the type of constraints you can specify. Yeah,
I understand exactly what you're saying, and the need has not come up yet, but it may be required to most generally satisfy a large group of users. Right now, we've gotten away with a lot with the repeater structure.
Right. Yeah, no, that's nice.
Yeah, it was nice. It was a nice, clean way of doing it. We liked it.
So Terry, this is, if I understand correctly, these are some problems that you address in Cypress with the PEAS framework?
We do, and I'm not crazy about our solution. Our solution is that we express the constraints in Perl.
Mm-hmm.
So I don't really like having it be dependent on Perl, but it does let us express absolutely anything that we need to. So yeah, I just wondered how other people might do it.
So I ran this monomer Monte Carlo simulation where it ran, how many did it run? 100 Monte Carlo iterations and filtered them off against the small angle scattering data. Joseph wanted an output similar to what he shows in his current GUI application, and so we have the text box area that shows up, and there was a progress bar that went by. And here's a plot. So it has, zoom and pan, so that's plot. And we're not utilizing all the capabilities of plot. So, yeah, that's basically the application. There's the newest version, Alpha, has some niceties that weren't quite there in the previous one, and that is that if you so let's say I go and I run something here. Here's some SAX data. Oops. It's got the full pan and zoom. Let's say I run this and I go to another module and I come back to it. It has it has what I had there before. And if I go to my jobs and I pick one of these up, here, let's go reattach. I selected 2. So let's go reattach. And it'll should reattach to that. This is our alpha. It works over here in this one, but the input, there wasn't reattach of input.
It wouldn't be a live demo if something didn't.
Yeah. Well, that's our alpha. We're making constant changes. So.
Yeah.
So here's what did he do? Oh, he's still debugging that. That's from SCT Analyze. That's the group from UCL. There's an error within his application. He did not have a key for that. So that's anything that comes back in the JSON output that is not matched to a field that you define in your output shows up as unexpected results. And if it gets unexpected results with an empty JSON return from the executable, it also goes out and grabs your standard error and tells you what that shows also. So this is all from the module executable underneath. We have multiple people writing things and debugging them in anticipation of the big workshop at the end of next month. So here's a integer repeater where we a repeat number of experimental curves and sorts of things. So that's basically it.
Great, thank you. Any other questions? Well, I have one last question or comment, which is that so right now this is not the code for all this is not public, but you have some at least drawn up plan or some sort of ideas about making it public.
Actually, it is.
Oh.
But it's not well promoted at this point. On the Gateway 105 UXC.org GenApp page is where we have our sort of our limited people know about wiki page that has it basically explains, setup, administration. Maybe not everything's perfect, but it's all there. We have the sources there. So, for example, here's, these are some user-generated setups, but the main, here's our languages. And so we have this sort of set of languages. And here's HTML5.json, like everything else. And here's where we just, and we've extended JSON a lot in our cases to support a comment line. So it doesn't, those are comments. But it has, this assembly list of how it builds things and how it loops over subsections and it weaves these applications together. So that's all. That's sort of the current HTML5 JSON. There's some JavaScript business, which varies closure minifiers. Copy's great when you're debugging because then you don't have to look at some twisted up JavaScript that you can't read. And then closure works really well. Seems to be make the minimum size JavaScript, the Google Closure compiler. So yeah, and then let's look at Qt4, and there's sort of some base code, and then there's the types. So I can look at something like let's go to something simple. Let's go to integer input. So here's a bit of C code for Qt4 that will be inserted where it is looking to display input an integer. So there's some validation business. There's some special directives and things that are peculiar to this. That's actually a JSON field, and it'll only insert this code if that field is set in the module JSON for that field that it's working on. And those are the values that are present. So it actually makes it kind of nice. But yeah, it's actually all out there at this point. But if somebody really wants to use it, and we've had people work through the docs, it's really probably go through and, you know, set up, probably contact me and talk to me about it and what your goals are. But you can try to work through it. I've had through 4 or 5 people actually work through these startup notes and get there. I did set them up a login on our gateway, but they've made local instances by setting up a local development system, checking out the code via SVN, setting it up, and then they can run the tool and generate, at least if they have Qt 3 or 4 running, they can get it going. Qt 5 I think also works, but I haven't tested it recently. So all the information is there.
Okay. We got a little bit of a late start, but we're getting close to after the top of the hour, so I'm going to thank Emory, and you'll need to give me back presentation control.
Okay.
Okay. Well, thanks very much. Emory's email was included in my announcement email, so if you want to contact him about any of this follow-up, you can look there. And also, of course, the slide link is there too. We'll have these the slides and the recording of it posted hopefully sometime by beginning of next week.
Thank you, Marlon, and thank you everybody for listening. And don't hesitate to contact me if you have some questions or application interest.
Thanks.